All right, welcome back. In the previous session, we have deployed a currency converter MCP server onto Cloud Run, and we have locked it down so that only authenticated users can access it. And we have integrated that with Gemini CLI, and we have tested it. Now, in this session, we're going to build a new client to our MCP server. It's an AI agent built using Google ADK framework, and we're going to deploy this AI agent to Cloud Run as well. We're going to make this AI agent publicly accessible and test it using a browser. But this AI agent itself must submit a token to get authenticated with the MCP server. This is a classic service-to-service security pattern implemented using Google Cloud IAM. Let's get into details. Let's take a look at the code components we have in the architecture here. So first we have an AI agent, which is an autonomous application which uses LLM to reason, plan, and execute tasks using specific tools. So powered by LLMs, AI agents, they move beyond static text generation to actively performing tasks such as automating complex workflows and business processes for users, etc. And we're using Cloud Run here for the deployment for various benefits that it offers. It handles concurrency and provides auto scaling so that your AI agent is always responsive, and at the same time it costs nothing when it's idle. And we have AI agents separated out from the MCP server, basically decoupling the brain from the tools. So agent is deciding what to do, and MCP server standardizes how to access the external systems. The bottom line is we're separating the logic from the access layer here, creating the modularity and control. All right, if you take a look at the internal flow here, first we'll access the AI agent service using the browser. So browser is making the user request, it's hitting this AI agent service endpoint. And then for this agent to make a secure call to MCP server, it first needs to acquire a self-identity token for authentication. So for that purpose, this AI agent service is hitting Cloud IAM and acquiring the token. And to interpret the user's intent, this AI agent needs to make LLM requests. So for that, it is communicating with Vertex AI model API. So for this demo, we're going to use one of the Gemini models. So it has several versions, Gemini 2.5, 3. So we're going to use one of those. And then agent is communicating with MCP server using the token that it has acquired in the previous step. And as a part of the tool call, the MCP server is making an API call to the external service. In this case, it is public currency API. And then the next step, this external service is responding with the currency data, and MCP server receives the response and it processes it, and it is sending it back to the AI agent service, and this AI agent service is formatting the final response and it is sending it back to the browser. Okay, that concludes the architecture, and now let's proceed towards the demo. As we've seen in the previous session, we have deployed an MCP server on Cloud Run, and we're going to deploy an AI agent which will be talking to this MCP server in this session. And we were leveraging ADK Python samples for this, and currency agent was the specific example that we were using. And this MCP server folder within this was what we have used earlier for the deployment of the MCP server onto Cloud Run. And now this currency agent subfolder is where we have the ADK AI agent code, and that's what we're going to focus on. And if you take a look at the currency agent here, within the agent.py is where we have the ADK AI agent defined, and here we can see an LLM agent created. It's a simple agent that is doing the currency conversions, and it is using the MCP toolset. We provide the MCP server URL here. So our MCP server is deployed on Cloud Run. That's a remote server that the endpoint of the Cloud Run service is what we're going to provide here for the MCP server. And this ADK agent is going to use that tool that we have within the MCP server to come back with the currency conversions. And this is the system instruction that is provided to this ADK agent. Now for this sample, we will need a Docker file to create the container image for the deployment of the ADK agent, and a fast API app to wire up the agent. So let's take a look at that code first. All right, so getting on to Cloud Shell environment here. And here is where the currency agent root folder is, and the MCP server and the currency agent. And the Docker file that we required, it looks like this. It's a standard Docker file that installs UV and dependencies, and it runs the ADK agent server, which will serve the agent API and the web chat UI. And now let's take a look at the main.py, which consists of the fast API app definition here. So this uses this get fast API app to automatically wire up the agents from the local folder. And we're passing web equals to true option, which enables the web-based chat UI. And here is where the server is starting, configured for the standard container deployment using the port variable here, which will be auto-injected by Cloud Run. Now, going back to the agent definition here, we're going to need some simple customization done to this agent.py so that it can securely talk to MCP Server. So let's do that. Now, my local copy already has those changes implemented, but if you take a look at the original file here, this is how it looked, the agent.py. It was a simple LLM agent definition which was taking the tools here based on the MCP server URL. Now this code needs some customization so that it can securely talk to MCP server. So those are the changes that I have already made. We can take a look at those changes here. Here we have a secure authentication mechanism to connect the agent to our external MCP server. We have the get auth headers function, which dynamically fetches the Google OIDC token to authenticate with the MCP server. And as we can see here, it uses the MCP server base URL as the target audience to acquire the token. And this function is then passed to the MCP toolset so that every request that's made to the MCP server includes a valid bearer token for authentication. And here in the root agent definition, we can see that the model that we're going to use is specified, which is a Gemini 2.5 Pro. And those are the changes that it requires. So with these new changes, it's going to be requiring Google Auth library, and that's what we're going to specify in the dependencies here. And also for this demo, we're going to use the latest version of the Google ADK, which is the 1.23. And so looking at a glance here, the Docker file, the new Docker file that we have created for building the container image, and then the main.py that we have reviewed, which is starting the ADK agent server, and then the changes done to agent.py to securely talk to MCP server, and finally specifying the dependencies in the pyproject.toml file. So these are all the changes that it required. So a link to these full code samples will be provided in the description for your reference. And now let's get to the deployment of the agent onto Cloud Run. All right, the first step for us is to create the service account to be used by the ADK agent Cloud Run service. So let's do that. So here's the gcloud command, which will perform that operation. Gcloud IAM service accounts create ADK agent SVCSA. That's the name of the service account that we're going to create. And we have the service account created. All right, the next step is to grant the required IAM privileges to this service account. The first one is going to be the Cloud Run Invoker IAM role, which is required for the agent service to securely talk to MCP server. And the second one is the AI platform user IAM role, so that the agent service can talk to the Vertex AI model API. So as we have seen earlier, our code is configured to use Gemini 2.5 Pro model, so that we're going to use from Vertex AI. And to access that model, we would need AI platform user IAM role. So let's grant those permissions. Here is the gcloud command to grant the Cloud Run Invoker IAM role to the service account that we have created for the ADK agent service. So now we have that permission granted. Now this is the gcloud command to grant the Vertex AI user permission to the service account. So it's the AI platform.user IAM role. Okay, so we have the service account created and the required IAM privileges granted. So if we go take a look at the service accounts and refresh, so here is how the service account looks. That's the full email of the service account. And if you take a look at the permissions, these are the roles that we have granted using the gcloud commands earlier. All right, next step for us is to perform the deployment onto the Cloud Run. All right, here is the gcloud command to perform the deployment onto Cloud Run. So we have seen this in the previous session during the deployment of the MCP server. So here this is creating a service called Currency Agent, and that's the service account that's going to be used by the agent, and we're going to be accessing it using the browser without authentication enabled, and the region in the US Central 1 is where it's deployed, and a few environment variables that this agent uses. First of all, we are accessing the model using Vertex AI. That's what this flag is representing. And then the Google Cloud project and the location. So these are the environment variables required for ADK agent so that it can access the model using Vertex AI. And then that's the MCP server URL. So our agent service is going to talk to the MCP server remotely, and this is the URL that it's going to use, and that's where our MCP server is. And the source is the current directory where we are, and that's where we have the Docker file to build a container image for the agent. So let's hit. All right, a container image build is just done. Now the deployment is happening. If you refresh here, we should see the deployment going on. It's creating a revision now. And it's just finished deployment. And here now we can see both the agent and the MCP server Cloud Run services. And if you take a look at the currency agent, we can see the endpoint using which we can access the agent. This endpoint exposes a web UI for interacting with the agent. We have used allow unauthenticated option for the deployment of the currency agent, which essentially gave agent's web UI a public access. So we are doing this strictly for this demo so that we can easily test it for our demo purposes. For a production environment, you would enable authentication for currency agent, requiring end users to log in to access it. As the deployment is finished, we can see the endpoint to access our agent. That's the ADK agent web UI that we have just deployed. So click on this drop down and then pick the currency agent, and let's do a simple test. All right, first let's try a query that doesn't require a tool. Something simple enough. Hi, how are you? And we can see that it came back with a generic response which did not require the tool calling. Now let's do the real test. Convert 100 USD to British pounds. All right, so that's our second query. This second query requires the agent to recognize that it needs a tool for the execution, and it needs to create the OIDC token to successfully authenticate with our MCP server and perform the tool calling and get back the result. Let's hit that. And that's what it comes back with. And it came back with the result that we exactly expected. And that was a secure authenticated service-to-service handshake. The agent provided its identity and the MCP server accepted the request, and we got the result that we expected. And that concludes our demo here. A small note here is that if you're getting a connection error for your initial test, such as fail to create an MCP session, it could potentially be an issue with the cold start with MCP server. So just retry it after giving it a few seconds. All right, as we've seen, we have built the full chain here. An end user facing AI agent and an MCP server, both running on Cloud Run, and crucially AI agent communicating securely with MCP server. That's it for this session. See you next time. Thank you.